Galileo Galilei stands as a towering figure in the history of science. Born in Pisa, Italy in 1564 during a time of great intellectual and artistic ferment known as the Renaissance, Galileo became a key player in the scientific revolution. This revolution challenged old ways of thinking and ushered in a new era of reason and observation. A true polymath, Galileo excelled as a mathematician, astronomer, physicist, and engineer. His work laid the foundation for modern science, championing a new way of understanding the universe based on observation, experimentation, and mathematical reasoning. Galileo's ideas, however, were often controversial. He dared to question the accepted wisdom of his time, particularly the teachings of the Catholic Church, which held a geocentric view of the universe. This placed the Earth at the center, with all other celestial bodies revolving around it. Galileo's work supported the heliocentric model proposed by Nicholas Copernicus, who argued that the Earth and other planets revolve around the Sun. This challenge to established dogma would have profound implications for Galileo's life and legacy. Galileo's journey into the world of science began in his youth. From a very young age, he exhibited an insatiable curiosity about the world around him. His inquisitive nature was evident in the way he would spend hours poring over books, asking questions and seeking answers. This early thirst for knowledge set the stage for his future as one of the most influential scientists in history. Born into a noble but not wealthy family, his father, Vincenzo, was a musician and composer who instilled in young Galileo a love for music and a keen sense of observation. Vincenzo's influence was profound. He taught Galileo to appreciate the harmony and mathematical precision in music, which later translated into Galileo's scientific endeavors. The young Galileo often played the lute with his father, and through these musical sessions he learned to recognize patterns and develop a disciplined approach to study. Galileo's education started in a monastery, where he was introduced to the basics of classical education. The serene and contemplative environment of the monastery allowed him to delve deeply into his studies. However, his intellectual journey took a significant turn when he later enrolled at the University of Pisa to study medicine. His father hoped that a career in medicine would provide financial stability, but Galileo's heart was not in it. However, his true passion lay in mathematics and natural philosophy, the study of the physical world. He found himself drawn to the works of ancient mathematicians and philosophers, spending countless hours studying their texts. The logical structure and clarity of mathematics fascinated him, and he began to see the world through a mathematical lens. His professors soon noticed his exceptional talent in this field, and he started to gain recognition for his insights and analytical skills. One day, while observing the swaying of a lamp in the Pisa Cathedral, Galileo made a crucial observation. This seemingly mundane event sparked a series of thoughts that would lead to a groundbreaking discovery. The rhythmic motion of the lamp captured his attention, and he began to ponder the underlying principles governing its movement. He noticed that the time it took for the lamp to swing back and forth remained constant regardless of the arc of the swing. This observation was not just a fleeting thought. Galileo meticulously measured the swings, using his pulse to time them. His careful and repeated measurements confirmed his initial observation, leading him to a deeper understanding of pendulum motion. This led him to formulate the theory of the isochronism of the pendulum, stating that the period of a pendulum's swing is independent of its amplitude. This principle was revolutionary because it contradicted the prevailing Aristotelian belief that the speed of an object's fall was proportional to its weight. Galileo's theory of isochronism laid the groundwork for the development of more accurate timekeeping devices such as the pendulum clock, which would come into use many years later. This early discovery demonstrated Galileo's keen powers of observation and his ability to discern fundamental principles from everyday phenomena. His method of systematic observation and experimentation became a hallmark of his scientific approach. Galileo's ability to see the extraordinary in the ordinary set him apart from his contemporaries and paved the way for his future discoveries. It marked the beginning of a lifelong pursuit of scientific truth, a journey that would revolutionize our understanding of the cosmos. Galileo's relentless quest for knowledge led him to make significant contributions to various fields, including astronomy, physics, and engineering. His improvements to the telescope allowed him to observe celestial bodies in unprecedented detail, leading to discoveries such as the moons of Jupiter and the phases of Venus. These observations provided strong evidence for the Copernican heliocentric model of the solar system, challenging the geocentric view that had dominated for centuries. Galileo's work laid the foundation for modern science, and his legacy continues to inspire scientists and thinkers to this day. Galileo's scientific method relied heavily on observation and experimentation, a departure from the prevailing Aristotelian philosophy which, embraced by the Church, relied on logical deduction rather than empirical evidence. Galileo's approach was revolutionary. He believed that to understand the natural world, one must observe it directly and conduct experiments to test hypotheses. His experiments with falling objects challenged Aristotle's notion that heavier objects fall faster than lighter ones. Through his meticulous observations and carefully designed experiments, Galileo made groundbreaking discoveries in physics. He formulated the laws of motion, including the concept of inertia, which states that an object at rest will stay at rest and an object in motion will stay in motion at a constant speed and direction unless acted upon by an external force. These discoveries laid the groundwork for Isaac Newton's later work on the laws of motion and universal gravitation. Galileo's emphasis on observation and experimentation became cornerstones of the scientific method, which continues to shape scientific inquiry today. Galileo's most profound contributions came in the field of astronomy. In 1609, he learned of a new invention from the Netherlands, the telescope. Intrigued, Galileo constructed his own telescope, improving upon the design to achieve greater magnification. With his telescope, Galileo turned his gaze towards the heavens, making a series of astonishing discoveries that shook the foundations of the geocentric model. He observed craters and mountains on the moon, challenging the belief that celestial bodies were perfectly smooth spheres. He discovered 4 moons orbiting Jupiter, providing evidence that not all celestial bodies revolved around the Earth. He observed the phases of Venus, which could only be explained if Venus orbited the Sun. These observations provided compelling evidence for the heliocentric model. Galileo published his findings in his book Sidereus Nuncius, Starry Messenger, in 1610. The book caused a sensation, bringing Galileo both fame and the scrutiny of the Church. His support for the heliocentric theory put him at odds with the Catholic Church, which viewed his ideas as heretical.